Hi there and welcome to Power Graphs. Drawing power graphs, I'm starting off with a very basic power graph. This is of the form y equals a to the x, and what I'm going to do, so this is of a form y equals a to the power of x. Now what I want you to look at is the fact that we have gone always through 0, 1, because anything to the power of 0, if I've got anything at all to the power of 0, any number to the power of 0 always equals 1. So it will always cross here at 0, 1. Okay, the standard graph that hasn't been moved to the left or the right or up and down always crosses at 1. You'll also notice that it gets closer and closer to the x-axis, that there is its asymptote. So the standard graph has its asymptote along the x-axis, and the y-intercept is always at 0, 1, one off from the x-axis. So it just goes up there 1. Right. The next thing that we need to know is we need to know what this value here is, this a value. And what we do is from this point here, if we go across 1, that means that the power is going to be 1. It will go up, it will tell us what the a value is. So at that point there, remember, at that point there we've got a y value of 2, and this will equal whatever our a value is to the power of 1, because this value here is 2. So in other words, it tells us if you go across 1 and up 2, that your a value must be 2. Right, if we draw another graph, let's draw something different. If we draw a graph like y equals 5 to the x, how about we have a look at something like this? Right, again you can see it goes through this point here, 0, 1. Again you've got the x-asymptote, the x-axis as your horizontal asymptote. Now then, if we go across 1 from where we saw this point here, go across 1, and then you go up 5. So this means that this one here, this particular graph here, will be y equals 5 to the power of x. Now the next thing that we're going to look at is what happens when we move it left and right or up and down. So okay, so how about if we do something, we'll stay with the 5 there, and we will put something like a +2, and then maybe a -4, something like this. Right, now you can see that your asymptote is along y equals -4. So that is telling you that on your graph itself, on the equation of the graph, what you have now got is you've now got that y equals something. You don't know what the a is yet. The x, you don't know what that is yet, but you know it's moved down 4 places. Next thing to look at is you're going to look at exactly when you go up from the asymptote, when you go up 1 from that asymptote there, when you're actually going up 1, so that distance there is actually up 1 unit. When that's up 1 unit, that tells you how far along this way that you have actually moved. And as you can see there, we have actually moved across there, we've actually moved 2 units to the left, which means that this up here must be +2. Only thing we've got left to work out here is what is your a value. Well, what you do is you come across here 1 unit, and then you just go up until you hit the y-intercept, the axis itself, the graph. Now if you do that, you count up 1, 2, 3, 4, 5. So you're going up 5. So that is where your number there comes from. Right, let's take a look at another one. Let's take a look at, we'll do a different base. Maybe base 4. We might put a minus in there, and then we might put like a +2. Let's have a look at this. Right, first of all, you can see that your horizontal asymptote is sitting at 2, and you can see that that point there, there's your magic point, it's sitting on the point 2, 3. Okay, so this means that we have got a y equals, and it's going to be something on the end, it's going to be moved up 2. Right, this magic point here, which is usually 1 up, again it's 1 up from your asymptote, so that there is 1, it has moved across 2 places to the right. So this means now that it is in x minus 2. You've just got to work out what your a value is here. Okay, if you go across 1 from there, you can go up 1, 2, 3, 4 until you hit this. Go 4 from your asymptote all the way up. So that means that that distance there is 4. So that tells you that this number in the front here is a 4. Okay, let's do one more. What if this is a 2 and that there is a 3 and this one is a 5? Right. Again, the very first thing you look for is where is your asymptote, your horizontal asymptote, and that one there is sitting at 5. So you know that you're going to have something which is going to be y equals something, and I'm going to have a plus 5 on the end. Now then, you go across until you go 1 up from the asymptote. There it is there. So you look till that is 1, and that has moved across 1, 2, 3, and it has moved across 3 to the right. Therefore it is an x minus 3. I've just got to work out what that number is. I go 1 across, and I've gone up 1, 2. So I went up 2, that means for that number there is 2. Okay, I'm going to do something a little bit different now. What happens if we've actually got a fraction in the front here? Something like y over 4. Right, a couple of things that we're going to do here. First we look where the horizontal asymptote is. So again, the horizontal asymptote is at 5. So therefore we've got this equation in the form of, got to turn my pen on. Got this equation in the form of y equals something, and I've got to have a plus 5. Right, then I look where my magic 1 up from is. It is actually 1 up there, so it has actually moved across 1, 2, 3. So therefore I know that this one here is going to be an x minus 3. I've just got to work out what this number is. Okay, so if I go, this time I'm going back 1, and I'm going up 1, 2, 3, 4. Okay, so since I'm going downhill, I can either put a negative in front there, or I can say that this is actually, because I'm going backwards, a quarter. Okay, that's just some basic drawing graphs. I'm then going to show you how you can actually get a different base in here where it's not just a whole number, but that will be in the next video. Thank you.